Mr. Oleg to talk about test containers. Take it away.
Hi, how are you? It's so nice to see all of you here, JFocus. I love this conference. I love to see how many of you are here. You are all amazing. I know you had lots of choices where to go, and I appreciate that you're here with me. Right. So, without further ado, let's start. We have 50 minutes. We're going to talk about test containers. We're going to talk about integration tests. And I intend this to be like a demo-heavy session where we're going to look at the actual examples of code and tests run. Hopefully, most of them run. Hopefully, some of them pass. But if not, we're going to, I hope most of us are developers here, and we're going to figure it out as we go. So it's going to be an interesting session. Right, my name is Oleg Selajev. I work as a developer advocate for the company called Atomic Jar. Atomic Jar is a startup which was founded by the maintainers of the Testcontainers Java library. And now more and more people are joining. And just recently, last week, we announced a very, very exciting thing. Two things, actually. We're excited that we got money for the Series A, which is excellent for any company. And also that we announced the public beta of a product called Testcontainers Cloud, which if you're using Testcontainers for your tests, I encourage you to take a look at, and it's gonna make an appearance on one of the slides and in the demos. Right, if you have any questions and you don't have time to ask it here, please reach out to me online. I'll be happy to chat with you about anything, about tests, about software development, about life in general. I'm old and wise now, so I feel I can offer some advice on this. But yeah, don't hesitate. And here as well, I know that we have a microphone somewhere here. So if you want to ask a question, shout. The microphone will come to you. You're going to ask the question in the mic, so people who are watching online can also hear the question, and we're gonna just roll with it. I love the sessions that are interactive. So if you have questions or if you didn't understand something, just ask. Because, well, it's much better than to wait for like half an hour and then forget what you wanted to ask and then come back and then be disappointed. I want us all be very happy that we're here. Right. Right. Yeah, absolutely. Right. We raised the round. We are hiring on a number of positions. So if you are looking to join a small but very interesting startup, reach out to Sydney. She's our person that is responsible for hiring, or just go on the website and check atomicjar.com/careers. Right, all that out of the way, let's talk about tests. Let's talk about development process. Whether you're actually a DevOps team or whether you are doing just software development using any other methodology, tests are very, very important. Tests are on the critical path from source to production, which is essentially, that's all that software development is about, is taking the source, changing it, hopefully for a lot of money, in certain ways, and then shipping those features to production. And tests are essential there. And tests can help you answer almost all questions in development. Right? Am I making progress towards implementing a feature? Well, do you have tests? And are they passing more than the last hour? If yes, you are making progress. Can you merge pull requests? Do the test pass? Then you can merge it. Are you breaking somebody else's code while you're developing? Well, can you run their tests? If their tests still pass, you're good, right? If the tests fail, maybe you broke something. So tests are very, very important. And I think this is my personal opinion. I think if we as a community, if we would test our code better, not necessarily more, but just if our tests are better, if we are more confident in software that we are building and we are releasing, the world will be a better place, right? There will be less broken software, and hopefully that will trickle out into the world to be a better place. Now, if we talk about the tests, maybe many of us have this picture of how we organize the tests. Sort of, this is the triangle, which people call a pyramid for some reason, but it's a triangle because it's a shape, not a figure. And the premise is that at the bottom we'll have lots of unit tests. Everyone would love unit tests. They will be isolated, they will be small, they will be testing individual components of our application, standalone, without any interaction with the outside world. They're going to be easy to write, easy to maintain, and they will be the basis of our test suites, of our pipelines. And then on top of them, we'll build some integration tests, which will exercise our system with different components in play, maybe some external systems. And they will be, historically, they were harder to maintain. They were like slower, they were flakier, and people didn't like it very, very much. And then we'll cover that with a little bit of the end-to-end tests, which will run in the environment similar to production, maybe like a copy of a production system or like a staging environment. And they will be even harder to maintain, and there will be even less of those. And everyone will mostly hate them because they will be flaky and hard to work with. So that was in the past. Now, more and more in the recent years, people have decided that maybe they should rethink what types of tests and how they test their applications. And many different teams came out with their thought process about how they organize testing their applications. There are different sort of approaches and different articles how people do that. This picture is taken from the article by Spotify, how they test their microservices. Specifically in the world where applications become smaller and the part of the behavior of the larger system is encoded in the interactions between different systems, right? Whether microservices or whether you're just using some cloud technologies or whether your larger services communicate via Kafka or some sort of other like message-driven architecture, a lot of importance is on how systems communicate with the other world. And that means that maybe you don't have to have that many tests that test implementation details. Like, it doesn't matter whether you test every individual method in all possible combinations. And what matters more is that your system should work in the environment with technologies that we actually will use in production. So more and more importance it goes towards integration tests, which will be a higher level. They will still exercise all the code, like in all the methods that we are writing, because that's what implements the logic, right? But you don't necessarily need to test on that lower level implementation detail level. And then the integration test can become the bulk of your test suite, and this is what you can use to make the decision whether a particular build is, well, appropriate to ship in production or not. Whether you do this automatically or require like a click of a mouse that just deploy this commit something. If you have high level confidence in your tests, which you usually can get with integration tests way more than unit tests, then you can build the more reliable pipelines. And then you still can have the integrated tests, which run in the environment similar to production with all the services spin up, like maybe a spare cloud account or something like this. But you maybe don't want to like have that as the bulk of your test suite to make automatic decisions. Because they are harder to maintain, they are more expensive to write and run. So the integration tests are sort of the sweet spot of the test we want to write. And then when we talk about integration tests, why is it also that people love them more and more recently? Is because they're much easier to write and create in a way that makes sense to developers, thanks to the technology progress. And in this session, we're going to talk about Testcontainers, which is the collection of libraries that simplify integration testing and allow your sort of unit tests run with the real service dependencies that you need. So sort of combining the best of both worlds. How many of you use Testcontainers? Yes, very good. How many of you like Testcontainers? Don't you dare answer yes for the first one and no for the second one. No, all opinions are valid, all opinions are welcome. But if you don't like it, please talk to us. We'd love to make them as awesome for you as possible. But this is great. Almost everyone uses that. Are you doing like web applications, microservices, mostly? Very good. Nice. Great. Spring people, hands up. Very good. Almost everyone. Quarkus, great framework by Red Hat, mostly. A few hands. Micronaut, a few hands. Very good. All great choices. Something else? Who does libraries for open source, like a database driver? One person. Good. Very good. Love it. Right. So Testcontainers, they're libraries. I'm going to skip some details, but just want to say, like, people and developers almost universally like it very much. Recently, the ThoughtWorks Radar put us into the adopt category, saying that this is a default option for creating environments for your tests, which is like very nice feedback, because the default option means that you should know what you're doing and why you're not trying to use it. So it's not why you should use test containers, but the opposite. And then test containers works in all compatible Docker environments. We run our own tests on different options, and it worked very, very well. Even on the things like Minikube, which is a lightweight Kubernetes distribution for developers, but it exposes Docker API, and the tests run with that very, very nicely. And of course, this is where the Atomic Jar product comes in. What we built internally is Testcontainers Cloud, which is the backend for your tests. Your tests run locally as usual, but you don't need a local Docker environment, but you get like an on-demand cloud environment while you run tests, and the containers run in the cloud, don't take resources on your machine, scale, because, well, the cloud scales very nicely. And in general, it gives you like the next level test containers experience that you would like to get on CI, on desktop. And it's currently, as I said, in public beta, so you can just go to testcontainers.cloud, smash the join button, register with the GitHub or Gmail account, and try it out. I'd be happy to receive any feedback. It's pretty great. And it's like, as I said, any compatible Docker environment would work. From Docker, we just need a number of things. Why it works? Because test containers uses the Docker Java API to talk to any Docker daemon, right? So we are not tied to any particular Docker environment. Obviously, test containers is an open source project. It sits on GitHub, and it does a number of things. But the most important things that it does is talks to Docker environments on one hand, and it integrates with your code, your application frameworks, and your test frameworks on the other hand, right? So, and what it does functionally, it needs to take care, in the testing framework, a framework like test containers needs to take care of three things. It gives you the programmatic API to manage the container lifecycle, cleanup, and the sort of container management things. It gives you the API to configure both containers that you run in the tests and applications within the containers. And it gives you the integrations with frameworks, as I mentioned. So we're gonna look, right? So this is great. And then the next best thing about test containers is that it comes with the ecosystem of modules, which is the predefined abstractions for the commonly used technologies, which allow you, the sort of the end user developer, not to worry about how to run a particular technology in a Docker container, but you can just declare, I want Kafka here, and boom, you get Kafka. Or you can say, like, I would like to run a MongoDB with like with sharding, which is a little bit awkward to do maybe on the pure Docker container level. But as long as you have the modules, the abstractions, you just add the library as your dependency in your project, and you get those abstractions, and you just, in a few lines of code, you can just get it, and you get the environment programmatically, which is very, very good. So it makes your tests standalone. There are no external configuration that you will forget to update. There is no external requirement to have some shared services to run in your CI pipelines or anywhere. And it makes your tests repeatable across all environments, right? All you need is to run your project, well, mostly, I assume, on the JVM, some Java projects, or maybe Kotlin or Scala, and have access to the Docker environment, and your tests will run the same way on your machine, on your colleague's machine, whether that uses, like, I don't know, Windows versus Mac OS, they will run the same in CI, and that means that you can have trust and reproducibility across the tests, which allows you to reproduce issues and fix them. And why is that important? Because you, as developers, are the only people who can fix issues, like it or not. But if something is broken, a developer needs to look at it, fix it, and ship it. No one else can do it. That is both the curse and the glorious reason to exist as a developer. Right, it's a great responsibility, great power. Right, so with all that, I can talk about how great test containers is for ages, but let's look at the demos. Let's look at the examples. Let's go into the IDE and let's see how it works. And what I would like to do is to go through a bunch of different examples and maybe show you not the most basic examples how to create the first test container, how to run your first tests, but maybe a little bit more real-life examples of that try to solve some common problems or show you maybe a little bit the next step that is not so obvious from the getting started docs, right? So, and if you have any questions, please don't hesitate to ask. Right. So this is what we have here. We have a Spring project, which is great because most of you said that you're using Spring. It uses Maven, so it has the bunch of test containers dependencies in our POM XML imported here. It's an application. The business logic of the application is not important, right? It's a sample application. What it does, actually, it talks about ratings for the sessions at conferences, which is obviously incredibly important use case. And it uses a bunch of technologies, right, to exist. So if we look at the ratings controller, so it's a web application, so it will bind to a port, it will ask for the ratings. It uses Kafka template to talk to Kafka. And different components, different classes in this enterprise application communicate via Kafka, because that's how we write software, for the examples. It uses Redis to store some data. So it stores some data out of the ratings in the session in Redis. And it also uses the normal relational database to store some other parts of data. It might be an overkill for such a simple app that does like just addition of numbers and showing them on the HTML page. But it's very nice because it uses a variety of technologies and it allows me to show different test containers features. So it needs Kafka, database, and Redis to work. And I have my tests here. If you look at the test folder, I have my demo application test here. It's the full test suite, right? I have my tests. I have my test that checks that the context loads, which my application combines correctly. I have my test that checks whether the health endpoint returns 200, that my application starts, wires up, and thinks that it's ready to go. It uses a very nice library called Rest Assured, which gives me a flexible programmatic API to create HTTP queries in a very fluid way for tests. It's incredible. And if you don't use it, take a look at it. So we can just say like when we get this endpoint, we expect 200, and if something fails, log something. It's very, very flexible, and it's programmatic. So what I like about programmatic API things, right? Why I like that, because as a developer, I might not know everything. And of course I could read the docs, like duh, but I don't wanna, right? If it's not in my IDE, it doesn't exist. I know, like if you feel you can relate, good. If you feel like you cannot relate, even better. But so why I like it, it's because I can type dot and the IDE will give me all the hints what I can do, right? So that's why I love it. And we sort of try, when developing our libraries, test containers libraries, we try to follow the same thing, right? We try to give you all the hints and all the possibilities right there in your IDE, not to make you go to, God forbid, documentation. Now, you should read the documentation. We take care in writing that as well. It's very important. But I know you. Right, so the test. It's a test that checks the health endpoint. And it's also, there is a test that checks the actual behavior, high-level behavior of my application. So what it does, it sends a request to the ratings endpoint and says that test container session has the ratings of 5, which I assume is good. And then it waits until the ratings responses will come back on the other side. So it uses the awaitility library for handling async events, which is if you're not using that and you're dealing with testing asynchronous events, that is an absolutely must that you should look at. Even if you will not take anything from the session except that, asynchronous events, awaitility, HTTP REST queries in the test, rest assured, 2 libraries that you should absolutely look at. We use awaitility internally in test containers extensively because there are a lot of things that we need to wait for. For example, for the container to start, we give Docker a command, start me the Postgres container, and then we need to wait for that to start. Obviously, we don't want any timeouts or anything like that. What do we use? Awaitility. And it starts, give us back the control, we're good. So We wait for the ratings to come out, and then we send more requests with ratings, and then we wait for them to come out, and then this is the proper high-level functional test. And if this works, I'm pretty sure my application can handle like production load, because it's a sample application, and this sample test is enough. We also have the negative test that something doesn't exist. It returns 404, which people very often forget, but we shouldn't. Right, so I have this test suite, and it has no setup yet, but I can have the setup with test containers very, very simply. So here, I will not type this in. I just want to like sort of a basic recap of what test containers allows you to do. The basic abstraction is a generic container, which allows you to run anything in a Docker environment. What it takes the image name for the Docker image name. In this case, I'm going to run Redis through this, and you can see that it will pull my Redis from my Docker Hub or any other Docker repository that I have, Docker registry, sorry, and it will manage the lifecycle of that. I can configure my container to do anything I want. In this case, I will expose the internal port on which Redis is running, so I can access Redis from the outside. And then if you wish, you can just type dot and also do whatever you want to do with the Docker container. You can do it with the API. You can specify the environments, you can specify the access, you can specify the dependencies on other containers that you want to start, you can specify, override the commands that you want to run. So all that right in your code, which is very, very good. Right, so we have the generic container for Redis. We have the Kafka, and since it's a simple application, instead of using any Kafka implementation, I'm going to use Red Panda, which is like a Kafka implementation that is written with the startup and performance in mind. So I'm going to use this. For my test, it starts faster than other Kafkas, so I like it very much. But you, of course, should be using the actual technology that you're going to run in production with. So if you're using Confluent Kafka in production, run with Confluent Kafka tests. Since this application doesn't go to production, because it's a sample application, I'm going to run it with Red Panda, which you can also use Red Panda in production, of course, if you do that, but just be mindful of that. And here, for the database, I'm going to use the JDBC support from Testcontainers, which is pretty magical. So when I configure the JDBC URL, what I can do, I can add the TC suffix, a TC part in my JDBC URL. And then when my Spring application is going to look which driver can handle that JDBC URL, everyone will say, no, 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 I don't know what this TC stands for. I cannot handle that. And the test containers driver will be like, yes, this is my time to shine. What it will do, it will look at the rest of the string. It will figure out what Docker image you want to run, which is Postgres here. And then what it will do, it will create the instance of that container. It will run it for you. It will configure it. And then it will pass to the actual Postgres driver to handle the JDBC stuff. So it will magically create the Postgres instance on the fly. So this is the simplest way to integrate test containers with your project, by just adding TC to your suffix if you're using a relational database. And it also, what is also very good about this example, that it shows that since it gives you test containers give you the programmatic access, right? You're not limited to only the things that we came up with or somebody came up with. You can build any kind of abstractions, because the thing that handles the lifecycle and configuration of containers is just code. And you do code all day, every day, except meetings, right? You can build abstractions that you want. So in this case, the abstraction is the JDBC driver that does a little bit and then delegates to the current driver. You have a question here. Can we get the mic?
As some of us may know, this Spring Boot application by default in Spring Boot is cached. So I'm curious, who manages the lifecycle of the Postgres database, of the test container? So if you have multiple tests with this Spring Boot test configuration in the top, how is the test container lifecycle managed? Is the test container restarted every time for a new test, or is it cached in the background?
That is an excellent question. How the lifecycle is managed. That's a very good question. I think this one is created when the Spring finds the JDBC driver. So it's created just once for every time that occurs. Or for every Spring Boot application that was created, it will create a new Postgres thing. But the lifecycle of the containers is a very big question in general, and we give you a lot of flexibility, right? There are a number of things, and the most basic thing is that you can create those containers yourself, and you can manage the lifecycle yourself, which gives you the full flexibility. So what I can do here, I'm also doing it here in this dynamic property source method, but what I can do redis.start, right? And this will start me the Redis container, or I can do redis stop. Stop idea, please. Redis stop, and it will stop my container. For example, if I have my tests, and if I want to do that for every test, I can use the normal test facilities like before each or before all to start those. I can also use things like static initializers if I want the containers to be started just once, or I can put them into the separate hierarchy of classes into a singleton. For example, if I want a certain environment to be created just once for the JVM process, that very much, when you use some heavier containers, like for example, local stack to mock AWS technologies, right? It's a little bit slower to start, and normally you just need one. You rarely need more than a single local stack instance for your test suite, because normally when your application runs, there is only one AWS. So it's supposed to run with a single instance of the cloud. And then that one, you probably just don't need to start again and again and again, because that is just using the resources too much, right? We would like to pull it out of your, in general, individual test initialization code and do that only once. But you can also do, like as I said, before all, before each. There are also the JUnit 5 extension that you can use. So you can do the test containers here, the annotation called test containers. Do I have it on my, yeah. So I have the test containers annotation, which will give me the possibility to run the containers automatically, and I can mark my containers with container, and this way JUnit extension will take care of the life cycle of this particular container. If you want. If it's a static field, it's gonna start it before the class and stop it after class, like before all, after all. And if it's an instance field, it will do that before each and after each. So if you want. But, well, I think, personally, you can do any type of lifecycle control. I feel that very often the manual lifecycle control gives you the most flexibility, and you understand exactly when your containers are started or when they're stopped. Later. Reuse is going to be later. So here I will do, the Postgres will be handled automatically. My Kafka and Redis will be handled manually. The startables, this is a nice little utility method that will start my Redis and Kafka in parallel. And I can run this. Now I can run this test. The containers will be started. The only thing I need is to wire the containers back into my application. For the Postgres, this is handled automatically. For my other things, I need to do that. And this dynamic property source method will take care exactly for that. I can use this registry to add the properties that will override all the configuration that I have statically in my application. So for example, I can say Spring Redis host, and I can do, where is my Redis running? Redis get host. Get host. Perfect. And I can do the same with my port as well. So port, Redis get mapped port. Get first mapped port. Very good. And it will provide the port configuration. Why do I need this dynamic configuration here for the ports? This is a very important point, because in the container, we're exposing a single port, and outside, it's going to be mapped to the random high-value port. Why? Because we don't want any conflicts. If we'll map it on the static port, on the fixed port, if I run 2 Redises, they're going to be a conflict. I don't want that, because I might want to run like a cluster of my Redises, or I might want to run my tests in parallel on the same machine. And that will mean that I will have double the containers, because I will have the containers in, well, every fork will get this set of containers. So every fork will get a Redis. I don't want conflicts there. So we try to make it very, very easy to parallelize your tests and never sort of impede your quest for productivity, faster running tests, and so on. So I do Redis. I also do Kafka. Does anyone know how to configure Kafka for Spring? No, I think it's the Bootstrap. I just need the Bootstrap servers, right? And then how do I get the Bootstrap servers URL? I just ask my Kafka container, which is great. This is where the module ecosystem comes in play, right? For the Redis, I needed to configure and say which image I want, how to configure it on the container level, where to put the configuration files. I don't need to do that with the modules. With the modules, I just add a dependency, and somebody else, hopefully smarter than me, most probably smarter than me, has written the code that tells me how to run Kafka container, that it needs to execute certain commands, that it needs to do certain things, and how to get the configuration for the Bootstrap server's URL. So as an end developer, I don't care how to run Kafka in the Docker container. I care that my application works with Kafka. And for that, I can use Testcontainers to just say, give me Kafka, and Kafka there is a question up there, please. Right.
Yeah. So I was wondering about the random port thing. If you have a need to set the port where the, to access the Docker, like I have Docker running in a VirtualBox. So I have to open the port in VirtualBox, I reckon, to access the, whatever, MySQL, for instance. Would it be possible to set the port statically?
Right. You want to still statically map the port within the container outside.
Yeah.
Yes, there is an API to do that, but it's not desirable. In many setups, that will just not work. For example, with the remote Dockers, that might not work. Then it's hard to maintain. With parallelization, it will break. In your particular setup, if you really know what you're doing, you can do that. But also, I will show you an example in a little bit how you can maybe overcome that to an extent, which might help or not, which I will get to very, very soon, like just right immediately. I can run now my tests, right? So this is my test, this is my setup, and it's perfect in all its glory. Right, so let's talk about database. The most important thing about database is not just to start it. You also need to initialize it, which is a very common problem, that you need to run your database migrations, or you need to populate your schema with some test data. And then there are a number of things that you need to do. So what we can do instead, we can do Postgres container, and we're gonna say, I don't want my my database URL driver handle that. I want it to have my manual control. So we're going to do new Postgres container, and I'm going to do the same Postgres, what was that, 14 Alpine. Check this out. Does it work? Yes. There is content assist in IntelliJ IDEA for strings in the API for Testcontainers. If that doesn't speak for popularity, I don't know what does. No, seriously, IntelliJ IDEA is a great IDE, and they add those sometimes small little features that are just make your heart sing. So for example, here, look, I can just pull Docker image right from like actions, which is pretty amazing, I think. Right, so I do the Postgres, and now I'm not doing the automatic transition here, and I don't want my application, what's the file? Application properties, application YAML. I don't want the Spring to handle my schema initialization, because I don't use that in production. And I want my test to be exactly like I do in production. So I want it manual. So I don't want this. What do I want? What do I want? What do I want? Maybe I want to have the database migrations with Flyway. No, I don't want Flyway yet. Wait. I want my schema to be initialized. I have a file that initializes schema. How do I do this? in an integration test, I can configure my container to have any configuration I want. So for example, for Postgres container, and most of the databases do this, what you can do is script. No, initialization. Script. Initialization scripts. If I put my scripts in a certain location in the container, they will be picked up and my database will be created, right? So what I need to do, I need to put my schema SQL file in there. How do I do this? With my programmatic API, I say with copy file to container, and I just say, give me the file, which is for class path resource, all this schema SQL, and I just say, put it in there. Don't be shy. One thing, and it's a directory, so slash goes to the end, not in the middle. And that's it. This little configuration, what it will do, it will make my schema SQL file appear in the Docker container at the proper path for the database to pick it up. So now I can still run my tests, right? If I do demo application tests, I can run, for example, my context loads, because for the database, I just need one, right? So this is much better because now Spring doesn't initialize my data. But I also can do the actual thing that runs in production. So for example, if I have my flyway, I can just have my migrations files. Wait, what happened? Peter, this is not supposed to happen. What? Wait a second, abstract integration tests. You need to be schema SQL with copy file to container. Yes. Oh my God. Thank you. We need to start Postgres. Duh. Registry at Spring data source URL. Because now the magical JDBC thing doesn't handle that, right? Postgres get JDBC URL. Luckily, I don't need to know anyhow how to build this. It's just a little configuration. Get username, and then one more is to get password. Get password. So now we just do password. Oh my God, people are clapping. You should clap. Please clap. If it runs, please clap. Yes, thank you. So they know, just so they know that we are having fun with curly and braces. Right, so we can do this. We can also do, what can we do? We can do flyway. And this will be very normal, and then we don't need to do this, but we just need to enable flyway, and our application will work with the database in the same way as it will do normally. Right, so now my database works there, and it runs on the random port, right, which is exactly what the question was. It runs on the random port. It's a little bit awkward because very often for the database, if I exit the presentation mode, because I didn't find the button here, maybe I want my database to connect to it from here, right, from my ID and explore the schema, and it's not ideal. It's not ideal because the random port maybe sometimes, well, I don't want to reinit the configuration for that all the time. So what I can do a thing, and for example, I can copy a certain dependency, which is the proxy, which will not conflict on the ports, right? So, but I can do this. Wait, port. Let me just do this very quickly. Reimport. Right? Where the project I took it from? Here. Yes. Excellent. So I can just give a little bit of configuration in my test that I will just say I would like to create the proxy, and when I'm creating the configuration here, I also want to create the proxy to the Postgres container. So why is it great? And it's a little bit small there because we'll enter the presentation mode very soon back. But what this proxy is doing is it takes the fixed port, and it takes that port and proxies to whatever the dynamic configuration for the database there is. I can, for example, use this proxy only locally, because only locally I care about having fixed ports. But now, I think if I run this again, where's my demo test, demo application test? The same string thing, and then scanner sc new equals new. Don't do this at home. System in. Be responsible. Next line. Be responsible. Set a database. Set a breakpoint like a normal human being. But we can run this test. So like this is just a scanner. It will stop waiting for the input, so the test doesn't finish, right? And my application starts. My proxy starts, and I can do the new data source. And this is what? This is localhost 5900 driver Postgres. Is this good? Test connection. Oh no. Supposed to work. Incorrect database URL. JDBC. No. Okay. Let's skip this. There is not a lot of time, but it's supposed to work this way, right? And I can assure you that it binds to that. I think it's just my IntelliJ prowess here. Postgres URL. Interesting. Maybe it's not test. No, it's supposed to be test. Okay, fine. Anyway, you can do the proxy, and then you can proxy that for your local setups. It will work. For your remote setups, you don't have to do that. Right. What else can you do? Except the technologies. Flyway, you can do flyway, configure just by adding dependencies. It will work the same way. What else do I want to show? Oh, Kubernetes. How many of you use Kubernetes? Very good. Do you use just to deploy your stuff, or do you actually develop for Kubernetes? Like operators and stuff? Anyway, what I can show you, this is a beautiful example of what the power of test containers. Check this out. What I can do in my tests, I can use a certain Kubernetes distribution that I can run as the test containers module called K3s, right? This will run my Kubernetes cluster in my Docker container, and I can then use that Kubernetes cluster as I want. So for example, here, what I will do, I will run my Kubernetes cluster. I will also configure it to use an external. Usually, a Kubernetes cluster will use etcd for the database. Here, I would swap it for my local Postgres instance, because I can, right? And then I can run it. I can say that my Kubernetes, please use my Postgres as the thing, which I also run in my Docker container via test containers. I put those containers on a single network, so you can build any complex topologies you want. So if you, for example, need Kafka and a schema registry is something else, you can build multiple containers, put them on the same network, and you're good to go. So here I will do that. I will get the Kubernetes. I will get the Kubernetes config YAML file, and I will feed that to my client config, and then I will do operations with my Kubernetes cluster by creating the namespace called Oleg. And this, I think, should work. So this will start. Look, and now it will start. Wait, Docker PS. Wait, maybe here. Docker PS. Right? What does it say? We run Red Panda, we run Redis, we run test containers rook. This is, oh, because the test is running here. Wait, this one, right? Stop. Stop. Finally. The scanner in was holding the containers, and then Docker stats, right? Now those old containers are all going away, which you know because you use test containers automatically, which is great. Right, so where's my project? Okay, here, right? So my Kubernetes was started, my Postgres was started, they worked together, they created the namespace, and I can use that. If you're doing any operator development or you work with Kubernetes, then you can do that, and you can create any complex setups. You can use AWS technologies with local stack to create your local AWS clone to test against, I don't know, like S3 or Dynamo, or you test your Lambdas if you use serverless with AWS. It's very, very convenient. You don't need to actually look at the YAML, which is another benefit of the programmatic approach. You know there is YAML in this string, but you don't have to actually look at it, which is great. Right, so you can do Kubernetes. And then the thing, right? So sometimes the containers start a little bit too long because they are heavy, and you don't want to maybe do that all the time. This is where the reuse mode, which is excellent for the local development, comes in. The reuse mode is when you instruct test containers to opt off automatic lifecycle control and clearing up the containers after your tests run. So if I have here in my application, where this go away, get me back to my sample project, new window. Here, abstract integration test. What I can do is I can say, for example, Kafka, I want to enable reuse with reuse true, and then, for example, my Redis with reuse true, and this will instruct test containers, if the environment supports this, not to clean up the containers. People. Right, so with reuse, what is the environment? I need to have my my test containers local configuration for the test containers properties, and I want to have the reuse flag in. So when I use API to say, please reuse this container, and when my environment says it's okay to not stop the containers, because, for example, you don't want to do this on your shared CI, because then somebody else will connect to your Kafka that you started 2 weeks ago, and they will spend 2 days debugging the issues, and they will be mad at you, not on me, at you. So you only want this in the environment you fully control, so you can specify that, and then when you run your things, your applications and your tests, the containers will start and stop it. The containers will outlive the environment setup, right? Well, it will be simple. And the last thing that I wanted to show is a very, very interesting feature. You can see this run, and I think if I do Docker PS, my Redis and my Red Panda are still there, because we opt out of the cleanup, and it's not just there. If I run the test without changing the configuration, test containers hashes the configuration for the container and adds the hash as a label to the container, and then if we know it's the same container with the same configuration, we will not start the new one. So that's how the reuse will be used, right? So your test can connect to the same container. So if you're using that for local development, it just speeds up because you don't need to start again and again and again. And if the configuration will be changed, the hash will not be the same, and then we will start the new container. And eventually you will need to clean up the containers yourself because you opt out of the automatic cleanup. So we cannot do that for you. But it's a very, very nice feature for the local development. And also, some people know that for people using Quarkus or Micronaut have the feature called, we have a minute, dev services or Micronaut test resources. So you can run your applications, and they will create the environment for you even when you just run the application, not even the tests, which is great because you can clone the project, run it, and it will bring the environment that you need. They use test containers under the hood to create those, but it's an absolutely amazing feature. There is a GitHub issue for Spring Boot to kind of look into the same. We're out of the time, so I will not keep you any longer, but I just wanted to say is test containers is, you can build anything you want. Right? You can build all the abstractions, put the networks, introduce chaos engineering into that, and do anything at all. There are also other languages, libraries in other languages. So we have colleagues who do Node.js or Go or .NET. Tell them that test containers exist, and they will love it. They will love you for it. And then those libraries are there, and they're capable. And of course, like you can do all of that just from your IDE, like you're supposed to. Right, local development services, look into that, or ask me questions about that. And then a few links on resources if you want to continue a journey of learning about integration tests. Thank you very much for coming.
Unfortunately, you used all your time. So if you have any questions, find him in the hallway.
Yes.
Thank you.
We don't have time for questions, but I will take my stuff out very slowly. So you can come in and ask, take a Testcontainers sticker.
Cut his microphone.
And just roll with me.